In this lesson, we're going to continue talking about factoring, but we're going to focus on factoring trinomials. And I'm going to highlight that for you. A trinomial is something that has three terms in it. So all the problems that we're going to look at in this particular lesson are going to involve factoring things with three terms. Grouping, what we learned last time, is what we'll use when there's four terms. So in my first example, these are review problems. We've already reviewed how to factor these trinomials. The idea is you're going to look for two numbers that have a product of that last number. So in this case, a product of 2. So two numbers with a product of 2, but a sum of the middle number. So sum of 3. And so in this case, well, 2 times 1 is 2. But 2 plus 1 is 3. And so the factors are going to be x plus 2, x plus 1. We can FOIL that out to check our work, and this will work. It will give us the trinomial. So example B is the same thing. There's an x squared, so I'm going to put in an x and an x. And then I need to find two numbers that have a product of the last number, negative 20, but a sum of the middle number, which is actually a 1. So 20 is 1 and 20, 2 and 10, or 4 and 5. And if we choose negative 4 and positive 5, that will add up to give us positive 1. So that means our factors are x minus 4 and x plus 5. Now we're going to expand on this. And in example C, the difference is we still have three terms, but now there's actually a GCF. All three of these terms are divisible by 2. And so we can pull that GCF out first and then see if we can factor it further. So again, I notice all three terms are divisible by 2. So I'm going to start by pulling a 2 out, and then I'm left with n squared. That's going to become a 9n, and 72 divided by 2 is 36. Now we can try to use that same process that we talked about before. We can try to find two numbers with a product of negative 36 and a sum of negative 9. Let's see, 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. Which can we get to add up to negative 9? Well, if we make the 3 positive and the 12 negative, that should work. So that means my final answer here, I'll keep the GCF, and then I'll just draw my two parentheses. There's an n squared, so it's going to be n and n. And then we discovered it's a plus 3 and a minus 12. So it's the same process, we just had an extra step. We had to take that GCF out before we could do the factoring. Now in example 2, we have a trinomial that doesn't have a GCF, 5x squared plus 36x plus 7. We can't take that 5 out. And so this problem is a little bit different from the previous problems because there's a number in front of the x squared, and that number is not a GCF. And so we're going to have to use a different method here, or a slightly different method. And I'm actually going to show you two different ways that you can factor this problem. And you can choose the method that you like best. The first method is just a trial and error method. And in this first method, we draw our two parentheses, and basically we just use guess and check until something FOILs out to give us the correct answer. And so the idea is you start by looking at the first term only, and you think about, well, how could I get a product of 5x squared? And in this case, there's really only one possibility. It's x times 5x, right? The only way you can get 5 is 1 times 5. And so I'm just going to guess and put the x in the first one and the 5x in the second one. And then I'm going to look at the constant, the last term only, And I'm going to think about, well, how could I get a product of 7? And there's really only one possibility again, 1 and 7. And so the guessing part comes in, well, where do I put the 1 and where do I put the 7? And so you just try putting the 1 and the 7 in. And it's a plus 7, so I'm going to try both plus signs. And then you have to check. And the thing you really have to check is when you multiply your outer terms and your inner terms, you need that to add up to the middle term. So in this case, my inner term would be 5x. My outer term is 7x. When I add those together, I get 12x. That tells me this does not work. I need a 36x. So I'm going to have to erase and try something else. And really the only other thing I can try here is I could put the 7 in the first parenthesis and the 1 in the second. So now my inners are 35x. My outer is 1x. Oh yeah, that does add up to 36x. And so this is my correct answer. And so in this case, the trial and error method didn't take that long because there weren't really that many choices to try. And so in some cases, this is going to be the fastest method. And some of you, I think, might like this method best. Now, there is another method. It's called the AC method. And I want to show that one to you as well. And you can decide which way you like better. In the AC method, so we'll do the exact same problem. 5x squared plus 36x plus 7. In this method, we start by taking the first number and the last number and multiplying them together. So 5 times 7 is 35. And so that tells me I need to find two numbers with a product of 35 and a sum of the middle number, which is 36. So I need two numbers with a product of 35 and a sum of 36. And so let's see, well, 35 would be 1 and 35, or 5 and 7. And 1 and 35 give me that sum of 36. So then what we do is we copy down the first term. And then instead of writing down that middle term, we use our two numbers to write two terms. So I'm going to get a plus 1x plus 35x, and then I just copy down the last term, the 7. And basically what we've done is we took something with 3 terms and we changed it so that it has 4 terms. The reason we do that is now we can use the grouping method. And so the first two I can pull out an x, and in the second two I can pull out a 7. And I know this is going to work because I have the same thing in both parentheses. I can take that 5x plus 1, pull that out front, and I'm left with an x plus 7. And notice I get the exact same answer. The disadvantage of this method was I think it's a little bit longer of a method. It involves more writing. But the advantage is it's a nice process that gives me the right answer. There's a little bit less kind of guesswork in the problem. So I'll do the next one using both methods. I don't care which method you use. If you prefer one to the other, you can always just use that one method. All right, let's take a look at part B. So trial and error method, I draw my two parentheses, and I start by looking at that first term only. And so the possibilities are, let's see, it could be, well, 4 could be 1 and 4. So it could be 1a and 4a, or it could be 2a and 2a. And I have no idea which one it is. I'm just going to have to make a guess. And so, I don't know, maybe I'll start with the 1a and the 4a. And then I'm going to look at the last term only and think about, well, how can I get a product of 6? It could be 1 and 6 or 2 and 3. And once again, I have no idea which one it's going to be, so I'm just going to have to make a guess. Maybe I'll start with the 1 and the 6. And then it's a negative 6, so one of those numbers has to be positive and one has to be negative. So I'll just put in a plus and a minus. All right, so then we check. 4a minus 6a. Nope, that adds up to negative 2a. That doesn't work. And so then I just have to keep trying until I get the right answer. If I switch the 6 and the 1, it still doesn't work. I put in the 2 and the 3, and I made the 2 a plus and the 3 a minus. So 8a minus 3a is 5a. This is close. I want a negative 5a. And if you find that you're just off by a negative sign, you can just switch the signs, and that should work. So let's see. Again, we want this to be a negative 5. So we need the 8 to be negative and the 3 to be a plus. So I put the plus with the 3 and the negative with the 2. And yep, that does work. So it took me a little bit longer this time. If this 1a and 4a didn't work, I'd have to try the 2a and the 2a. So sometimes there is quite a bit of guesswork. But if you can do mental arithmetic in your head quickly, it can actually be pretty fast. All right, what about the AC method? In that method, so we'll do exact same problem. 4a squared minus 5a minus 6. So we take the first number and the last number and we multiply them together. 4 times negative 6 is negative 24. So I need to find two numbers with a product of negative 24 and a sum of negative 5. So product of negative 24, sum of negative 5. 3 and 8 should work if we make it a positive 3 and a negative 8. So once again, what we do is we copy down the first term, and then we use that 3 and negative 8 to break the middle term into two terms. So plus 3a minus 8a, and then we copy down the last term, minus 6. Now we can use that grouping method. First two terms, I just pull out an a. In the second two terms, I'm going to pull out a negative 2, and then I'm left with 4a plus 3. So the 4a plus 3 comes out front, and I'm left with an a minus 2. And I get the exact same answer. Now, just like earlier, when we are factoring, it's a good habit to always look for a greatest common factor first. And so in example C, these numbers are huge. And I also see m's in all three terms. And so I think there is a greatest common factor. We can definitely pull an m out of all three. But we can also divide all three by 2. And in fact, I think we can even divide them by 4. And so I'm going to try to take a 4m out of all three terms. And then I'll have something that's a little bit easier to work with. So I'm left with 11m squared, and then minus 2m, and then we pull out the m, and 52 divided by 4 is 13. And so now we can use the trial and error method, or we can use that AC method. I think this time I'll just use trial and error, because there aren't a ton of choices. 11m squared, it has to be an 11m and a 1m. And then I look at the last term in 13. Well, it's got to be 1 times 13. If I put the 1 here and the 13 here, well, 11 times 13 is huge. There's no way I'm going to be able to get a 2 out of that. And so I can save myself some time and not even try that. How about I put the 13 here and the 1 here? I get 13m, 11m. I need this to add up to a negative 2m. So that means the 13 has to be negative and the 11 has to be positive. So I'll make the 13 negative and I'll make the 1 a positive. And that is it. This is my final answer. Notice that final answer also includes the GCF in it. Don't forget to put that GCF into your final answer. All right, last example. This one looks a little bit different because it has an x to the 4th and an x squared, but it turns out we can factor it the same way we've done the other ones. We can use either trial and error or that AC method. If we want to use trial and error for this problem, because that first term has an x to the 4th in it, we're going to have to put x squareds in the first two spots. X squared times x squared is x to the 4th. And then product of 6, Well, it could be 1 and 6 or 2 and 5. No, I said that wrong. 1 and 6 or 2 and 3. Let me write that down. 1 and 6 or 2 and 3. If I use the 2 and the 3, then, yep, 2x squared and 3x squared does add up to 5x squared. But again, you can use that AC method. You'd be looking for two numbers with a product of, let's see, 1 times 6 is 6, so product of 6, sum of 5. Those numbers are 2 and 3. So then you could write out the first term, x to the 4th. And then for the middle term, you'd write it as two terms. It'd be a 2x squared plus 3x squared. And then your last term is still the 6. Now we've got 4 terms. We can use that grouping method. Pull out an x squared. We're left with x squared plus 2. Pull out a 3. We're left with x squared plus 2. So I'll bring that x squared plus 2 out front, and I'm left with an x squared plus 3. All right, that's it for this lesson. Factoring is going to be a really important topic. We're going to keep using it in the next several lessons, the next chapter. So please let me know if something about this doesn't make sense.